Hello, it's Michelle here, and what I'd like to do is I'd like to take some extremely small groups of observations from an extremely small group of participants, and it's made up data, by the way, and I would like to do a dependent or paired t-test calculation by hand, just to kind of get a handle on what this test is doing. So the first thing that we want to note with these data is that there's 3 people and they each gave us 2 different observations, one at time 1 or condition 1 and another one at time 2 or condition 2. So for example, P1's observation or score at time 1 was 13, and then at time 2 it jumped up to 26. Participant 2 started out time 1 with an observation of 19, and that jumped up to 22. So you see they each kind of have like an increase pattern. And when we calculate a dependent t-test, what you need to focus on is not so much like what's going on in this group. Sorry, it's really fuzzy when I move. What's going on in this group or what's going on in this group, but what's going on when you compare the difference between the 2 groups. Okay, that's enough waving my hand. So what we're going to do first is we're going to write the formula for a dependent t-test. So that formula starts with t equals, and then you have a mean on the top. And it's the mean, but it's not the mean of time 1 group, and it's not the mean of time 2 group. And it's not the mean of time 2 minus time 1 or anything like that. It's the mean of the difference scores. We haven't calculated those yet, so we shall, so that we can get the mean of the differences. And you have to divide that by the standard error for this test, which the way that I write it is SD squared, the variance of the difference scores, which again don't yet exist. And then you divide that by n. And n in this case is the number of pairs. So n is not count all the observations up and then that's 6 total, so put a 6 there. Because we're dealing with differences between folks, you only focus on how many folks are there or how many pairs of data are there. So that's what n is. So in our case, n is going to be 3. Wow, that was horrible. So when we do this calculation again, we're focusing on differences between folks and looking at those as if there are data, because they will be. So we're going to make this t go away and we're going to focus on getting the data ready. So in order to find the difference score, it's called, for participant 1 between time 1 and time 2, you could go 13 minus 26 and you'd get minus 13. Or you could go 26 minus 13 and get plus 13. The thing is, you have to be very consistent about how you do that. So you can't just be like, oh, I always want positive numbers, so every time I go to a new participant, I'm going to subtract the bigger number from the smaller number. That's bad. Don't do that. Instead, we're just going to start with this, and it's going to be like 26 minus 13, and then this is going to be 22 minus 19 for participant 2, and then finally 24 minus 19, because we always start with time 2 and then subtract time 1. And I'm going to write those actual values in now that you see my process. So here, this is 13. Here, this is 3. And here, this is 5. So the difference in the conditions or the times for each participant are shown here. P1 has a big difference, P2 has a relatively small difference, and P3 is somewhere in the middle. Okay, so to find, remember we have, if you remember, for the dependent t-test, we need to find the mean of the difference scores. And now that we have them, we can find that. So that's 13 plus 3 plus 5. Just divide that by the number of them, and there's 3 of them. So divide by 3. And when you do that, you end up getting 7. The top is 21. 21 by 3 is 7. But this is the interesting part. You might think, I'm just going to pause here, and I'm going to sneak in with my red marker. You might think, okay, why do I have to calculate these? And then I have to get this when I could just go mean 1 minus mean 2. Like, what's the difference between the mean of the differences and the difference of the means, which is a horrible sentence, but I think I know what you're saying. So if you do the mean 1 here, I'm just going to do it up here, try not to disturb anything. You go 13 plus 19 plus 19, divide by 3, and you get 17. And then if you do M2 here, just for time 2 data, you do 26 plus 22 plus 24, you divide by 3, that's 24. And lo and behold, when you go 24 minus 17, you still get 7. So you're like, if it's the same, then why am I doing this? Okay, sometimes it's the same. Sometimes it's not the same. So if you're caught up on that, I think that's totally fair. What I'm going to recommend you do in that case is stop doing this example for a second. And I want you to instead replace this data point, it's fake data, so it's okay, with this, no, that's not what I wanted. Oh! All right, here. What I meant to do, okay, sorry. If you're confused about why we can't just go mean 2 minus mean 1 and we have to create these scores and then do it, replace this one with a 19. That's what I meant. So then what you'll have is you'll have 13, 19, 19, and you can calculate this mean. And then you'll have 26, 22, and 19 for the second group. So assuming in this new situation, this is 19, by the way. Here, there, is that better? No? Okay, it's 19. And then what you can do is calculate the new mean, and you'll find that I believe in that case, the mean of the differences is not the same number as the difference of the two means as if they're independent. So you really have to link them with making these different scores first, because in a lot of circumstances, you won't find that they're equal if you kind of treat them like separate means and subtract. Okay, this was 24, so I'm gonna go back in time and put that there. Anyways, after you find the, oh my goodness, there's so much. How did this happen? I spilled some, there's ink everywhere and I don't know why. Okay, that's fine. So now that we have that, what do we need? So if you recall or wrote down the formula for the dependent t-test, the bottom part, the standard error, it looks like the variance of the differences, and then you have to divide that by the number of pairs. So we still need to find the variance of the differences. So am I going to get through? I think I'm going to just, oh my goodness, there's red ink everywhere. Okay, so then what we'll do is we'll find that. So the variance of the different scores, right? The way that you do that is you find the sum of squares of the different scores, which are these, and then you divide by the degrees of freedom for that group, which is n minus 1. So the way that's gonna look, just really like as a kind of, oh, I already forget how to do this because it's been a while and now I'm learning t-tests and I don't remember how to do a variance. So that would look like the sum of, you take a score, you subtract the mean of the different scores and you square it, and then you do that again and again until you run out of scores. And you divide by n minus 1. There are 3 of them, so n minus 1 is equal to 2. And I show you what this actually looks like, but you could skip ahead if you don't want to see it, or you could calculate it yourself and come back if you do need a refresher. But the first score is 13, so I put the 13 here and I subtract the mean of those, which is 7, square that. Second score is 3, so I go 3 minus 7, and then I square that, and then 5 minus 7, and then I square that, and I divide that whole thing by 2. And then if I do all of that, I get 56 over 2. But this might take several steps, or doing it all in the calculator carefully with brackets where you need them. Like what's in your calculator before you press equal should look like this. And then you would get, divide the end result by 2, and that is 28. Okay, so If it's not given to you in a problem, at least now you know how to calculate it. The mean of the difference, not the mean of the difference, the variance of the different scores is just a normal variance formula. And you're not square rooting. You might be like, where's the square root? I remember there being a square root. Well, with variance is the square of standard deviation. So if we need a variance, we use a symbol that has a 2 to remind us that it will be squared, and you don't have to take a square root of it. This is what we need to put in the formula as is. Yes, so good. Okay, we're about to find the t-value. All right, so let me put my summary statistics up here. We together calculated the mean of the different scores, which was 7. And then we calculated the variance of the different scores, which was 28. And now we shall put them into the t-test. The top is the mean of the different scores. What, on average, is the change for participants when they jump from time 1 to time 2? And the standard error, which is the variance of the different scores divided by the number of pairs. And that's saying, associated with this sample, with this size, what is the error that we need to account for, because we don't know the whole population of all of the people that we could measure. We just have these folks creating our own unique sample. And so we need to account for that using the standard error, which is the error associated with not having the whole population on hand. Oh my goodness, the suspense is killing me. Okay, so we're gonna put a 7 up top, and then you're gonna pause this if you wanna practice on your own. And I'm gonna put the 28 here. I'm gonna divide by the number of pairs, which is 3. Or the number of different scores, that represents the number of pairs just fine. That's also 3. And then you need to kind of do this. So I'm going to simplify a little bit, especially with fractions within square roots on the bottom. I just kind of want to take my time. So 28 divided by 3, rounded to 3 decimal places, is 9.333. So my next step will be maybe to simplify this bottom a little more, but I ran out of room. So these fellows can also go away. So the next step then is I have 7, and then the square root of 9.333 in your calculator, rounded to 3 places, should be 3.055. Or that's what I got. If you didn't get it, then maybe I'm wrong, but that's what I got. And then when you do this division finally, you get 2.29. And that is the observed t from our data that we observed. It's a dependent t-test, and the result is t equals 2.29. And you can keep 3 decimal places if you want. I didn't. I'm not sure how you feel about that, but that's how you do it. You see, the interesting part is that we're just so focused on the differences between groups. We don't care too much to examine the 2 groups independently, because they're not. And when you end up doing this, then the bottom of your dependent t-test, which is the standard error for that test, once we simplified it, it doesn't look like square roots and variances anymore, but this is the number associated with the standard. This is the standard error. Then like what it's taking into account is that since you're looking at differences between participants, you don't have to worry about the fact that there's 2 separate groups, because really there's 1 participant giving 2 observations, so they're the same person. So you can just focus on the differences between them, and you're not losing any information doing that. If this was an independent t-test and you did that, that would not be a good way to represent the data. So yeah, that's about it. That's all I want to say. Oh, you might be wondering what to do with this number. Okay, that's fair. So then what you're going to want to do is you're going to want to find your critical t-crit, or I call it my t-min. This isn't division. I'm just saying, like, find whatever it is you know this to be in a t-table. And we need the degrees of freedom, so you can use the t-table. And the degrees of freedom associated with this test are the degrees of freedom associated with this important data set we created here, and that's n minus 1. And that in this case is 3 minus 1. 3 minus 1, this is a 1. I'm not sure if you know this. Does that look more like a 1? Yes, thank you. 3 minus 1, and that's equal to 2. So you'd have to look right up at the top of your t table for the degrees of freedom equals 2 and make a decision about whether t observed is actually greater than the critical or minimum t, and that's about it. Amazing.